Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So with figure 6.5 in mind, we can apply Newton's second law to the x-axis, where here we are replacing the static frictional force with the kinetic frictional force where it is appropriate. So the kinetic frictional force minus the weight sine of theta will be equaling to the mass times the acceleration, where of course the mass is equaling the weight over gravity. And so here the weight is equaling 40 newtons. Here the acceleration is equaling positive 0.80 meters per second squared. And here theta is equaling 25 degrees. So we can find the kinetic frictional force. This would be equaling to ma plus w sine of theta. And after we plug all of our variables in, we find that the magnitude of the kinetic frictional force is equaling 20 newtons. Now, keep this in mind. We are going to say that along the y-axis, we can say that the normal force is going to be equaling to the weight cosine of theta. And so we can say that then the normal force, or rather, we can say that the coefficient of kinetic friction will be equaling the magnitude of the kinetic frictional force over the normal force, and this is equaling the magnitude of the kinetic frictional force over the weight cosine of theta, and this is equaling 20 newtons, of course, divided by 40 newtons multiplied by cosine of 25 degrees, and we find that then the coefficient of kinetic friction is equaling 0.56. This would be our final answer. That is the end of the solution. Thank you for watching.